Welcome back to another video in this series where I show you how to build a racing drone, freestyle quad, whatever you want to call it, every single step from a pile of parts on the desk to a finished quad ready to fly. I've taken all of the information that is scattered all over the internet and put it into one video series. I kind of want it to be a masterclass for how to build a quadcopter. And in this one, we're getting kind of close to the end. And like, what are we going to do in this one? There's just kind of like a bunch of odds and ends that we're going to wrap up. So let's get into it. We're going to go into Betaflight. We're going to connect to the quadcopter, and like, there's just some stuff that we got to wrap up. And we're just going to go through the tabs and find all of them. And I think at the end of this one, we'll basically be ready to button it up and go do a maiden flight. Let's see how it goes. We're going to start here in the ports tab because there are still a few peripherals to configure, and one of them is the GPS. So we've got the GPS on, yeah, there we go, sensor input GPS on UART1. And there's one other thing, which is the telemetry setup for my FrSky receiver. We'll get to that in just a second. So we're going to enable GPS on UART1 and hit save and reboot. Then we're going to go to the configuration tab and we're going to enable GPS. And we want to set the GPS protocol from NMEA to uBlocks and hit save and reboot. And one thing we're going to notice is that this little blue LED on the GPS starts blinking quickly, and that's going to indicate that the GPS is talking to the flight controller. And the other thing you're going to see is here in the GPS tab in Betaflight, even though we're in my basement, there's still a couple of satellites bouncing signal in the window or whatever, and I've got just barely getting a signal from a couple satellites, and that tells me that this is basically starting to work. What you're really going to want to do is leave this outside after you finish building it. Leave it outside for about 5 minutes with the battery plugged in, let the GPS sort of get a fix, and then you should see that you've got a 3D position fix. You should see some satellites in the, well, we'll see how to see the number of satellites and so forth. But the fact that we've got a couple of satellites even being detected at all confirms to us that the GPS is talking to the flight controller and it's working. If you're ever trying to set up a GPS and it's not working, one of the things you can do is you can change the baud rate here. The baud rate, the GPS units can support many different baud rates, but they'll ship with a certain default baud rate. And if you can't find a reference in the product page or whatever to what baud rate it should be using, you can just try each of them one by one and see if it works. The other thing you might try doing is here in the configuration tab. The protocol again should be listed in the product page for the GPS unit you're using. You can try changing from uBlocks to NMEA. And you can try auto baud and auto config, but they don't always work. The next thing I want you to do is on the right-hand side of the configuration tab, we're going to go down to the arming angle, and we're going to set the arming angle to 180 degrees. Betaflight has a feature by default where if the quadcopter is not flat and level, it will refuse to arm. This is a safety feature. If you're like carrying the quad in your hands and it's just dangling it by your side and you accidentally flip the arm switch, it'll refuse to arm. But it's pretty annoying, and most everybody who isn't just a total noob turns it off. You should be aware that if you do turn it off, you're disabling an essential safety feature, and you need to take other precautions to prevent yourself from accidentally arming the quad. Like previously I told you, you can raise the throttle and that prevents the quad from arming. The reason we turn it off is that if the quadcopter's like on a hill or it's like kind of on a rock or something and it's not level, then it'll refuse to arm, and that's just pretty freaking annoying. So I disable that. You can too, but you should know what you're getting into if you choose to do that. The receiver that we are using, the Jumper R1, has analog RSSI output. Analog RSSI output means that the receiver outputs a voltage on that wire between 0 and 3.3 volts, and that voltage is proportional to the strength of the RSSI, the signal strength, so that lets you know when you're about to fail-safe, when you're flying too far away. It's kind of like the number of bars on your cell phone, right? You get down to 1 bar, you drop the call. Well, that's a fail-safe. Because our receiver has analog RSSI, we're going to enable the RSSI ADC option. Most receivers don't have this, and most receivers that want to get RSSI are going to use a different method. I've got a couple links in the video description to a couple other ways to get RSSI if you're using an XM Plus receiver from FrSky, if you're using an RXSR, or if you're using Crossfire. Those are the ones that I personally have experience with and know how to do. Links in the video description if you want to get RSSI working with any of those. And I'll hit save and reboot here. Over here in the system configuration section, I'm going to encourage you to set a gyro update frequency and a PID loop frequency of 8K and 8K. And after I save and reboot, I'm going to come back to the configurator and I'm going to look at this CPU load right here. What I want to see is that CPU load is below 50%. If that CPU load is over 50%, you would want to reduce those numbers from 8K down to 4K or maybe even lower. You're seldom going to have to go lower these days. An F4 processor is fast enough to run Betaflight, at least Betaflight 4.1 on 4K, 4K, or 8K, 8K, depending on what you're doing. If you enable certain features like bidirectional D-shot, then you wouldn't be able to run at 8K, 8K, but we can. The faster sampling, it's better, although it's subtle. The idea is you want to run that faster if you can, and if you have to run it slower, that's okay too. Betaflight defaults to 2K because some ESCs, very old ESCs, can't handle the faster signals, so they default to 2K for compatibility reasons, but your equipment definitely can handle 8K, 8K, and you should definitely use that. Here in the configuration tab, there's another option, D-shot beacon configuration. Now this quadcopter doesn't have a beeper on it. So if you were to crash in some tall grass or maybe crash in a tree and didn't see where you went down, you might have difficulty finding the quad. A beeper is really helpful for finding the quad when you lose it. Although you don't have a beeper on the quad, and you could install one, but we're not going to, it has the option to make the motors beep, just like when you plug the quadcopter in and the motors beep. We can do that by enabling the D-shot beacon configuration RX set option and RX lost option. And this will cause the motors to begin beeping when you trigger the beeper mode or when you fail safe and lose signal. It's very helpful. I definitely recommend having a beeper on all your quads. If you don't have a beeper, use this option. Here in the power and battery tab, we can check the voltage scale and see if it is accurate. Here we can see that the battery is being read as having 15 volts. You can also see that up here at the top of the screen, even if you're not on the power and battery tab. It's not a bad idea to get out a multimeter and just check your battery voltage and see if it's reading correctly. But in almost all cases, the default scale is going to be correct and the voltage will read correctly. If the voltage ever did not read correctly, you could raise or lower the scale, and that would cause the voltage being read to go up or down to match whatever you were measuring with like a multimeter. Don't rely on like a cheap cell checker. A cheap cell checker is often not actually that accurate. I mean, it's good enough to know if like your battery's dead, but it's often not accurate enough for like calibration like this. You should definitely use, even an inexpensive multimeter is probably pretty accurate. And that's what you should use if you want to check or calibrate this. To tell you the truth, I don't calibrate most of my quads. I assume that they're accurate. Every so often, what'll happen is I'll plug a battery in. I know the battery's fully charged. I know it's at 4.2 volts per cell, but then the quadcopter will show that it's at like 4.3 volts per cell. And then I'll go, oh, this one needs to be calibrated. And I'll go back and I'll check it. Down here, we've got the amperage meter, and it is reading 65 amps, which is sort of screwy because clearly we're not pulling 65 flippin' amps from this quadcopter. It's just sitting there doing nothing. And the fact is that happens a lot when your current meter is just miscalibrated and not set up correctly. If we go back and look at this flight controller that we're using, I actually think the ESC doesn't have current sense at all. I don't think that this flight controller will do current sense. We can see here for the ESC plug that there's 5 volt, there's 4 signal wires, and there's a battery. There's no current sensor output. We can see that the flight controller has a current sense input. That's this CRT pad here. But since there's no current sensor anywhere on the quad, like it would be on the ESC if it was going to be anywhere, we actually can't do current sensing. Since that's the case, we're just going to go here and we're going to take the current meter source and set it to none. And we're not going to have current sensing. Now you might think that we'd want to start tweaking the PIDs here in the PID tuning tab, but no, I'm going to leave that alone for now. We're going to fly it on the default PIDs and we're going to see how it flies. PID tuning is a whole separate topic, and I do that for all of my quads. I usually will just leave the PIDs alone and try the defaults and see how they fly, and then I'll tweak them if I feel like I need to. In the rates, I do like to change the rates. These are the rates that I like to use. Yeah, those are the rates that I like to use. Every pilot's rates are individual. I've got another video about how to set your rates. And I've actually got another video, which is a discussion I did with Alex Vanover. He's a pro racer, and we talked about like just how you might choose to think about what you want your rates to be. How should they be, fast or slow? So there's one video about the mechanics of setting rates and another video about sort of the philosophy, and I'll put those links in the video description. You're welcome to fly the default rates. They're not terrible. My rates might be a little bit fast for some beginners, although I think they're probably pretty manageable. It's up to you. If you want to copy them, you can, or leave them at the defaults. And we'll save that. The next thing we got to do is really kind of fun, and that is set up your on-screen display. And this is something that every pilot personalizes the exact way they want, and you can sort of figure out what you think is best. The first thing I want to do is just check that the video format is set correctly, because as you can see, a PAL camera has more scan lines and the image is effectively taller. Whereas an NTSC camera has fewer scan lines. And if you have it set to PAL and then you drag all this stuff down here, but your camera is actually NTSC, the stuff will be off the bottom of the screen. Well, you see it bumps it up. It's smart enough. So what I'm going to do is I'm going to set it to NTSC, and I'm going to drag this warning element all the way to the bottom of the screen. And I'm just going to look at my camera, and I'm going to see if that warning element is actually all the way at the bottom, or if it's not quite at the bottom. And if it's not quite at the bottom, that means that this is not an NTSC camera, it's a PAL camera. And in fact, that's what I've got going on here. So when I set this to PAL, it looks consistent with what I see on the DVR. And if I drag this down to the bottom now, you can see it is in fact all the way at the bottom of the screen. So we're going to set this to PAL, and we're just going to leave that there. Auto works, but if it's set to auto, then what you see here on the screen doesn't match what you see in your goggles, and I prefer to just manually set it. So then, what you can do is you can turn on individual elements, such as battery voltage. That's kind of an important one. Battery voltage tells you when it's time to come home, and you're going to kill your battery. And then you can drag those elements around the screen and put them wherever you want. Now here is the OSD the way that I always do it. I can see that, craft underscore name. I got to go to the configuration tab and name the craft. I name it Know It All. That's what I just put in as my call sign for all of my quads. And here in the OSD tab, this is what my OSD is going to look like. I'll tell you the way I've got it set up. You can copy it if you want. Many people like it differently. It's personal. But what I like to see is I like to see the cell voltage instead of the pack voltage, because if you fly multiple different voltages, 4-cell, 5-cell, 6-cell, what is a fully discharged 4-cell battery? Well, it's about maybe 14.5 volts. Well, what about a fully discharged 6-cell battery? I don't know that one. Is it 22 volts? Is it? I'm not sure. But by using the cell voltage, I can just see 3.9 volts, 3.8 volts, 3.7 volts, and know that when that hits about 3.5, 3.6 volts, it's time to come home, regardless of whether I'm flying a 4S, a 5S, a 6S battery, or whatever. So I've got battery cell voltage. I've got current draw. Now in this quad, we don't have a current sensor, so there's no reason to have that turned on. So that's just, we're going to turn that off. I would normally have a current sensor, and I would want to know how many amps my motors were pulling. Milliamp hours. We don't need that because, again, milliamp hours requires current, and we don't have that. Milliamp hours is like a fuel gauge. And if voltage says you're down to this many volts, milliamp hours is like you've got this many sort of miles left. It's like distance to empty. Yeah, that's a fair analogy. So just two different ways of looking at the question of how close is your battery to empty. Craft name, I like to put the call sign in the upper left, so if spectators are watching, they can know what channel they're on. Some races require this, but I think it's a nice thing to do, even if you're not racing. The fly mode tells you whether you're in angle mode or acro mode. If you're doing GPS-assisted stuff, it's going to tell you that. Here you can see it says stab, which means stability or angle mode. Yep, it just tells you what's going on there. The RSSI value. This is the, like the number of bars on your cell phone, lets you know when you're about to fail safe, when you really need to turn around and come home instead of keep flying further away. I've got that. I feel like that's very important. The fly min, or timer 2, which is fly min, that is configured here on the timers, the flight timers. Timer 2 is set to the total armed time, or fly minutes. It's the amount of time I've been flying. And this is useful because I know that, like, on a typical freestyle flight, I might get 3.5 minutes of flying. So if I look down and I see that I flew for 4 or 4.5 minutes, I know the battery lasted particularly long. If I look down and I flew for 2 minutes, I know the battery didn't last very long. So fly min. You can have 2 timers, and those timers can be whatever you want. The total time since you plugged in, the total time you were armed, the time that you were armed if you disarm and rearm, it'll show you just your last flight time. And you can also change the precisions here. If you want to see hundredths or even tenths of a second, go ahead, although I feel like seconds precision is plenty. Now, because we've got GPS on this quad, we're going to want to add a couple of additional elements to the screen. And one of those is going to be GPS sats. This is one of the most important elements if you're flying with GPS. It is the number of satellites that you currently have locked on. Betaflight, if you're using GPS modes, will not let you arm with fewer than 8 satellites, because at fewer than 8 satellites, you don't have enough precision and the location data could be inaccurate. In our case, we're only going to be using the satellites for just sort of anecdotal information. We're not actually, with iNav, we're going to use the sats for actual autonomous flying. But with Betaflight, it just doesn't really do that much at all. Kind of bad at it. So we want to know the number of GPS sats, and it's fun to know. I like to put GPS speed up there. How fast is your quad going? That's kind of cool to know you were flying 80 miles an hour or whatever. So we'll put GPS speed up there. If you're doing longer distance stuff, you might want to put the home direction, which will tell you if you fly off into the distance and you're turning around and you're like, which way is home? It's surprisingly easy to get disoriented if you fly a distance. The home arrow is useful, and home distance. Home distance is the distance to home. I don't really care about that. Maybe it'd be useful if you were like, well, how far away from home did I get? Did I get a mile away? That's pretty far, but you could do that. I'm going to leave that off personally. I'm not going to mess with that, but those all might be useful things to know. And of course, you could put GPS latitude and longitude on screen. I kind of hate this because they take up so much freaking space on screen. But the idea here is that if you put the latitude and longitude on screen and then you lose your quadcopter somewhere out in the middle of the desert, you can look at your DVR and know what your last GPS coordinates were. There's one more OSD element that you need to know about, and it is probably the most important element here. It is the warnings element. Now, this element I've got right here in the center of the screen. This is important because if something ever goes wrong with the quadcopter, the warning element will tell you, or me, whoever you're asking for help, it'll tell you what went wrong. So you have to have the warnings element turned on. In fact, it's the only OSD element that's actually on by default for everyone in Betaflight 4.1. Don't turn that off, leave it on. But there is one thing that I think is super annoying. Here on the right-hand side of the OSD tab, you can decide which warnings you want to be warned about. And I think some of these guys we can ignore. And the one I most want to ignore is the core temperature warning. Sometimes the flight controller, the processor, gets hot, and then the OSD is just yelling at you, core temperature high. I don't know why some flight controllers run hot and others don't, and I've never had it matter. I've never had a flight controller freeze up or lock up or light on fire, so I just turn the core temperature warning off, and it's never been an issue for me, and that's what I'm going to suggest you do as well. Here are the warnings that I think are important if you want to go ahead and turn those on. Launch control. I don't do launch control. If you're racing, maybe you care about that. Yeah, those are the ones that I think are important. Battery critical. The OSD is going to blink at you when the battery is low, so I leave that off. Maybe you like a little extra warning that the battery's getting low. You could turn on battery critical or battery warning. RSSI. If you want like a warning on screen when the RSSI starts getting low, turn that on. But I just keep an eye on my RSSI, and when it gets low, it blinks at me, or I just watch it. So I don't worry about that. Now that's how I like to set my OSD up, and that's how I'm going to leave this one. You can play with all of this data, and you can have your OSD as cluttered or as sort of nice and pristine as you feel comfortable with. If we scroll down a little from there, we can find the post-flight statistics. The OSD will pop up a screen when you disarm the quad and show you your post-flight statistics. And you can choose what you want to see there. You can see here what I've selected. I think for this one we should add, because this quad has GPS, let's add the max speed so we can see what our fastest speed for the flight was. And anything else? Nah. Flight distance? Maybe. I don't really care about that. Turn that on if you want to see at the end of your flight how far you flew. I think I'm going to leave it there. Altitude maximum. Altitude maximum here. Leave that off because you're not supposed to exceed 400 feet, right? And if you would want to turn that on so you could confirm that you had not exceeded 400 feet, or turn it off so there's no evidence. There's just a couple more things I overlooked elsewhere in the playlist that I got to get out of the way here. There's just nowhere else to put them because I can't go back and insert them into those videos. Here in your radio, if you're using OpenTX, when you load this model, you're getting a warning that your switches are in the wrong position. And here, let me show you that. The last thing I want to do is here on the black box tab, I want to change the black box logging from 1 kilohertz to 2 kilohertz and save and reboot. Now, this is not going to affect most people at all. But if you ever ask somebody to help you with a problem and they say, could you send me a black box log? You're going to want to be logging at 2 kilohertz in my opinion. So go ahead and change that now, get it out of the way, and then you'll never have to think about it again. So when you load this model, you're getting this switch warning, and it's telling you your switches are not in the expected position. The idea here is that when you start the quadcopter up, when you load the model, you want to know that like you're in acro mode and your quad is disarmed, and so it warns you if the switches are not in the expected positions. And we need to just tell it what the expected positions are. So the way we're going to do that is we're going to press the model key, and here in model setup, we're going to scroll down to here, switch positions. And what I want you to do is put the switches into the neutral position. So for me, all of the switches are pushed away. They're pushed away, except for the arm switch, which is pulled towards. That's just how I do it. Put your switches in your neutral positions, disarm, etc., and then highlight this line and long press, and it will take the current switch positions to be the defaults. So you won't get that warning anymore. And then I started showing you how to set up SmartPort telemetry with soft serial. Oh, doesn't that all sound exciting? And I realized there was a problem and I got super frustrated and I forgot to record the outro. So I'm going to put that in the next video. But I believe other than SmartPort telemetry, which if you're not using FrSky, you don't care about that. Even if you are using FrSky, you might not even care about that. So other than that, we are ready to put this quad back together and we're ready to fly it. I think we're nearly done. Thank you guys for sticking around on this long journey. I hope you've learned a lot. There's going to be more. This playlist isn't over. Even after we get the quad quote unquote finished, there's still the iNav side and there's still little improvements to make and so forth. But that is going to do it for this video. Stick around for the next video where we'll do SmartPort telemetry and then hopefully we'll put it all back together and fly it. Happy flying, you guys. See you in the next one.